With the popularization of the public internet, the limitation of the address space, that is, the list of usable TCP/IP addresses provided by the IPv4, became a concern. When IPv4 reached prevalence in the 1960s, no one foresaw the internet explosion of the 90s that would have threatened to exhaust even 4 billion plus IP addresses available through the IPv4 system. While the use of private IP networks and NAT have, let's say, alleviated the problem somewhat, a long-term solution is still required. To this end, IPv6, the next generation of the IPv4 or the TCP/IP protocol, was developed to provide a significantly larger address space for the current and future implementation of the TCP/IP networks. IPv6 uses 128 bits or 16 bytes for addressing. That means that it will be providing about 340 billion unique addresses. To put this in perspective, the IPv6 address space would allow each human being on the planet Earth to possess multiple IPv6 IP addresses that were assigned only to them without ever being reused. IPv6 address notation is quite different from the dotted decimal of IPv4, using the 8 groups of 4 hexadecimal digits separated by colons. IPv6 includes a few other enhancements for performance and security. Notable IP security through the use of IPsec as an integral part of IPv6, whereas it was kind of optional feature under IPv4. Unlike IPv4 addresses, which are 32 bits in length and expressed in dotted decimal notation, IPv6 addresses are 128 bits in length and expressed in hexadecimal notation, quite a change for everybody who is used to the IPv4 notation. If an IPv6 address contains a series of sequential zeros, the address can be shortened to use a single zero in each group, or else the entire grouping can be represented using a double colon. You can find more about this notation on page 94 of the book. IPv6 addresses fall into the following types: link local address, unique local addresses, global addresses, multicast addresses, and special addresses. The link local address is an IPv6 unicast address that can be automatically configured on any interface using the link local prefix FE80 two colons /10, and then the interface identifier in the modified EUI64 format changed to 64. The link local addresses are used in the Neighbor Discovery Protocol and the stateless auto configuration process. Nodes on a local link use a local link address to communicate. The nodes do not need globally unique addresses to communicate. The IPv6 router must not forward packets that have link local sources or destination addresses to other links. Next in our list, we have the unique local addresses. A unique local address is an IPv6 unicast address that is globally unique and is intended for local communications. They are not expected to be routable on the global internet and are routable inside of a limited area, such as a site. They may also be routed between a limited set of sites. A unique local address has the following characteristic. It has a globally unique prefix. It has a well-known prefix to allow for easy filtering of site boundaries. It allows sites to be combined or privately interconnected without creating any address conflicts or requiring renumbering of interfaces that use these prefixes. It is ISP independent and can be used for communication inside a site without having any permanent or intermittent internet connectivity. If it's accidentally leaked outside of the site via routing or DNS, there is no conflict with any other addresses. And applications may treat unique local addresses like global scope addresses. The IPv6 global address are similar to the IPv4 public addresses. These global addresses are globally routable. The structure of an IPv6 Unicast global address creates the three-level topology, which means a public topology, a site topology, and an interface of a specific node on that site. The IPv6 multicast addresses are similar to the IPv4 multicast addresses. Packets addressed to a multicast address are delivered to all the interfaces that the address identifies. And finally, as with IPv4 networks, IPv6 reserves addresses and network for a specific usage. You can find the list of these special addresses in Table 311 on page 96 of the book. Now we're going to talk about the configuration for clients for IPv4 and IPv6 in Windows clients and server. You always need to provide to each client in your environment with an IP address that allows them to communicate with other clients on their subnet or other networks. You can use the following configurations on a client for IPv4: the DHCP configuration or the manual configuration. We also have the APIPA addresses configuration and the alternate configuration. In cases where you do not want to manually configure IP addresses, you can use DHCP. DHCP, as we know, automates the allocation of IP addresses through a server-based role that maintains a database of available IP addresses and other configuration information that can be provided to the nodes via DHCP. All Windows Server 2008 servers are set up to use DHCP by default. If the server you are deploying uses DHCP, you don't need to configure anything else. You should have the DHCP service available for your clients or have a static IP address. In cases where you cannot contact a DHCP server, even though the client is configured for dynamic addressing, Windows uses the automatic private IP addressing, or APIPA, to assign a unique random IP address for the addresses range from 169 to 5410 to 169 to 54 to 54 to 55. APIPA addresses allows clients on the same subnet to communicate without DHCP or manual configuration. However, APIPA addresses are not routable, so they cannot access resources on other networks. No internet access, people. Then we have the alternate configuration, which is an additional setting that you can configure along with DHCP. With alternate configuration, you can set up a static IP address in your IP configuration that will be used if DHCP is not available. On the other hand, we have the manual configuration. Manually configured IP addresses is often referred to as a static configuration or a static IP address. In this case, you provide your clients with a predetermined IP address that is available for use on your network, and the client retains this IP address until it's changed on the client. You do this by manually entering the IP address, subnet mask, and any other network services information required on each client that will be using a static IP address. You can use the following tools to perform this task: the initial setting wizard, the server manager, or the next command line. Static IP addresses are commonly used on server where a dynamic IP address will affect the network resources. And that's why we do the reservations on DHCP servers.